today's lesson, we are going to talk about easy steps. We have easy steps on writing, ionic equations. Ionic equations. So we are going to follow 4 steps on writing ionic equations. So step number 1, what you're supposed to understand or to know is to how to write a balanced, you should know how to write a balanced chemical equation, and you're going to see an example. So e.g. or example, we have barium nitrate aqueous, meaning it is a soluble salt. So the reason as to you are writing these two is because barium has a valency of 2 plus copper sulfate aqueous. It gives us, they always exchange their radicals. So we have barium sulfate, and it is solid, plus copper nitrate, into bracket we have copper nitrate, which is aqueous. So it has to be balanced first. So we are going to count the atoms of each element that are present in this equation. So we have one barium, we have nitrate. So how many nitrates do you have? Because of the bracket, it's going to be affected by these two. So we have 2 nitrate atoms, and in this case we still have 2 nitrate atoms. Then we have oxygen, we have 3 oxygen in the bracket. Then you multiply by 2, we have 6 plus 4, those are 10. Then in this case still we have 4 plus 6, those are 10. Then we have copper, here we have 1 copper, and this is 1 sulfur, 1 sulfur and 1 sulfur. So this equation is balanced. That is the first step. The second step we have is to write an equation. With free ions. Write an equation with free ions from all the compounds. Whose state symbol is aqueous. This means that the only ions that can be separated is for the compounds that have an aqueous state. So for example, barium sulfate, because it is solid, you cannot separate the ions, whether they are in liquids, in solid or in gaseous, you cannot separate them. But we only separate or write equations with free ions that have state symbols which are aqueous. So we are going to have, so let's write this note. So compounds, let's have this note. Compounds whose state symbols are solids. So we have solids, we have liquids, we have gases. Do not, that is G, they do not release ions. And so we are going to write this equation with free ions. We are going to separate the compounds with their free ions. So we have barium. So it has a valency of 2, so it has 2 plus with a state symbol of aqueous, because the whole compound is aqueous. So the free ions are going to acquire the state symbols from their respective compounds. So we have barium 2 plus aqueous, plus nitrate. We have 2 nitrates here, so we are going to have 2 nitrate ions, negative aqueous, plus copper with a valency of 2 plus aqueous, plus sulfate ions, negative aqueous to give us, we've said that compounds whose state symbols are solid do not release their ions. So we are going to write this barium sulfate as it is. So we have barium sulfate, solid, plus we are going to separate these ions for this compound because its state symbol is aqueous. So we have copper 2 plus aqueous plus 2 nitrate ions, 2 nitrate ions aqueous. Now we've known how to write a balanced chemical equation. Then the second step was to write an equation with free ions from all the compounds whose state symbols are aqueous. As you can see, barium nitrate had a state symbol of aqueous, so we've been able to separate the two. Also copper sulfate. Then the barium sulfate we've not separated it because the solid state does not release their ions. So number 3. So allow me to clean up here. So allow me to clean this one first. So step number 3 is we omit all the spectator ions. That is, when you talk about spectator ions, we are talking about the ions that are present on both the reactant side and on the other product side. So in this case we had barium 2 plus aqueous plus 2 nitrate aqueous plus copper aqueous 2 plus sulfate ions aqueous 2 negative. Then on the product side we had barium sulfate solid plus we have copper 2 plus aqueous plus nitrate 2 nitrate ions. So this is what we are talking about. When we are talking about omitting all the spectator ions, it means if we have ions that are present in the reactant sides and are present and are the same as the ions in the product side, we omit them or we cancel them. For example, in this case we have barium ions. In this side, in the product side, we don't have barium, so we don't cancel or we don't omit the barium. Then we have the 2 nitrate ions. In the reactant side we have 2 nitrate ions, and in the product side we have 2 nitrate ions, so we omit them by cancelling them like that. Then we have copper 2 ions on the reactant side. We still have copper ions in the product side. They are the same, so we cancel them. So we've remained with barium 2 ions plus sulfate ions and barium sulfate in the solid state. So step number 4 in this case, we are going to write an equation for the remaining ions. Write an equation for the remaining ions and compounds. And that is, it is the Ionic equation. So for example, in this case, we've remained with barium, so we have been asked to write an equation for the remaining ions. So in this case, in the reactant side, we've remained with barium ions. So we have barium 2 plus aqueous plus the sulfate ions. So we have sulfate ions aqueous. And in the product side, we've remained with a compound. We've been asked to write an equation for the remaining ions and compound. So the compound that we've remained with is barium sulfate solid. So that is how we write ionic equations.